Hi there, this is HESI Chemistry video number 8, and it is the last video in the atoms and elements section. And we're going to be talking about the periodic table. There are just a few things from the periodic table that have shown up on previous HESI tests that it would be good to memorize. So I've got this kind of summarized over here, and then I'll go into a little more detail about what it all means. So the periodic table is divided into metals, which are highlighted now, and nonmetals. And so nonmetals there's a lot fewer of them. They're on the right side of the periodic table. Metals are on the left side and all of the center. And the section of the periodic table also will tell you whether they have a positive or a negative charge, and in some cases what that charge is. So all metals always have a positive charge when they're parts of compounds. And all of the alkali metals, the yellowish orange highlighted ones, will always form a ion with a +1 charge or oxidation state. The ones that are most important for you to know are these over here: lithium, sodium, and potassium. The alkaline earth metals, most important ones there to know are beryllium, magnesium, and calcium, and they will always form a +2 charge or oxidation number when it's part of a compound. One of these that we know has shown up in past HESI tests is magnesium. So if you're asked about the charge or oxidation number of magnesium when it's part of a compound, the answer is +2. You do not need to worry about these that show up at the bottom. Transition metals are in the center, and these that are here labeled post-transition metals, just lump them all together in your mind as transition metals. Those are the metals that you've always known were metals even before you took a chemistry class. Things like iron and copper, zinc, aluminum, silver, and gold. I don't think you necessarily need to know their chemical symbols. Can't hurt if you know them, but definitely know if you see anything about any of these metals. And we know that iron has shown up on the HESI in the past. Just associate those with being transition metals. You do not need to worry about their charges or their oxidation states. The nonmetals that are all over on the right side include the noble gases. Noble gases are very special because they're very stable. They don't generally form compounds. Most common ones to know are helium, neon, and argon. And then for the others, the reactive nonmetals, the ones that you're going to want to know are the halogens that are all here: fluorine, chlorine, bromine, iodine. They always are going to form a -1 ion. Oxygen is -2, and nitrogen is -3. And I'm going to show you a little bit more about why they have the charge that they do. So, okay, so these are drawings similar to what we looked at in the previous video about electrons. The alkali metals all have, sorry about that, the alkali metals all have one lone electron in their outermost shell, and that one electron makes them unstable. They want to get rid of that electron, and then they become a +1 ion that is much more stable than the neutral atom was. And so we looked at that with lithium in the last video, but sodium behaves the same way. It also has this one lone electron out there that it wants to get rid of, and potassium, and all the way down. The ones you should be familiar with here are lithium, sodium, and potassium. The alkaline earths are similar, except they form a +2 charge, and that's because they have 2 electrons in their outermost shell, and they want to get rid of both of them. And when they do, they form a +2 ion. So for those, the ones to know are beryllium, magnesium, and calcium. Know that all 3 of those, if they're in a compound, would have a charge or an oxidation number of +2. And then it's easiest if we skip over to the noble gases. Those are ones that already have a full outer shell of electrons, so they don't want to gain or lose any electrons. They're very happy the way they are, very stable, and they're usually just going to remain as stable gases all by themselves and not form compounds. And then if we go one to the left of neon to fluorine, then because it's one to the left of neon, it has 1 fewer electron when it's neutral, which means it's got this gap here. It wants to have an electron here, and it does not. So if it can find an electron to fill that outer shell, it's going to be more stable, and it's now going to have a -1 charge. And the same is true for everything below fluorine. The chlorine, bromine, iodine are all going to behave the same way and form -1 ions. And then to the left of fluorine, of course, is oxygen. And since it has 1 fewer electron compared to fluorine, it has 2 spaces here where it would like to have electrons. So if it can fill those 2 spaces with electrons, it now has a -2 charge. And so on with nitrogen, that nitrogen has 1 fewer electron than oxygen, so it has 3 spaces that it would like to fill. But here's the neutral nitrogen atom, and then with 3 added electrons giving it a -3 charge. So that sums up what you need to know from the periodic table. And so just real quick to go over it again, the metals all have a positive charge when they're parts of compounds, and the alkalis have a +1 charge. Lithium, sodium, and potassium are the most important ones to know. Alkaline earth, +2 charge. Beryllium, magnesium, and calcium are the most important ones. Transition metals are all the things that you think of as just metals, such as iron, copper, zinc, aluminum, silver, and gold. Non-metals are all on the right side, and they are either going to be noble gases that do not form compounds and do not form ions and therefore do not have a charge of any sort, or the reactive nonmetals that will form a negative ion, also known as an anion, and that will be a -1 charge for the halogens, a -2 charge for oxygen, and a -3 charge for nitrogen.